We're going to start off with the first lesson that we're going to cover in Chapter 8 is 8.2. Chapter 8.1 deals with the graphing of logarithms, and since we do not have graphing calculators, we're going to kind of bypass that lesson. And the first thing that I'm going to talk about is exponential equations. That is when our exponents are going to have variables or letters in them. Okay, now there's a property of equality, and what that really means for exponential functions is that there's a rule that we can apply that if our problem has the same base on both sides, then we can kind of drop our bases and x equals 5. Okay, our property of equality says that if b, which is our base, is greater than 0 and b does not equal 1, then x equals 5 if both my bases are the same. Okay, now let me explain to you how that's going to work. Okay, so looking at this equation, we are solving for x. So our goal is to get x by itself. So therefore, my first step is we want our bases, which is 2 and 8, to be the same number. Well, how in the world can I get 2 or 8 to be the same number? Well, I can change what 8 looks like. We've talked about this before. So if I have 2 to the x equals, now how can I change 8 to look like 2? Well, 8 is really 2 cubed. So all I did was I changed what 8 looked like. Okay, not changing the problem, just change what it looked like, which is okay to do. Now, you learned in Algebra 1 that whenever you have an exponent raised to a power, you're supposed to do what? Multiply. So we have 2 to the x equals 2 to the 9th, because 3 times 3 is 9. Now, this goes back to our property of equality that says that if our bases are the same, we can drop them and x equals 9. There's x. Okay, very, very easy. So let's look at example B. I have 9 to the 2x minus 1 equals 3 to the 6x. My first step, got to have the same basis, which I don't. I have a 9 and a 3, but we can change 9 to have a base of 3. So I have 3 squared. Still got 2x minus 1 equals 3 to the 6x. Okay, now in order for me to simplify this, I can multiply my exponent by my power, but I've got to do the distributive property. So I'm going to come over here, and I have 3 to the 4x minus 2 equals 3 to the 6x. Now, how did I get that? 4, 2 times 2 is 4. 2 times 1 is 2. That's how I got my new problem. So now my bases are the same, so I get to drop them. So I have 4x minus 2 equals 6x. So here's my new problem because I dropped my bases. So now I just simply solve for x. So negative 2 equals 2x, so x equals negative 1. There's my answer. Okay, same problem. C. I have 4 to the 2n minus 1 equals 64. What do I need to do? Same base, and I can have a base of 4. So I have 4, 2n minus 1 equals 64 is 4 cubed. We've already learned that. So I have the same base, they drop, and I simply solve for n. So I have 2n equals 4, so n equals 2. Okay, now same rules apply, nothing changes, even if I got an inequality. So I need to have the same base, so I can either, the same base that 16 and 8 can both go to is 2. I can change 16, 2 to the 4th, 2x minus 3, and 8 is really 2 cubed. So what do I need to do? Multiply that out. So I have 2 to the 8x minus 12 is less than 2 cubed. Okay, from here, what do I need to do? Drop my bases. 8x minus 12 is less than 3. 8x is less than 15. So x is less than 15 over 8. There's my answer. And I'm done. That is chapter 8.2.